In this video, we will recap the key concepts when dealing with discount rates. So up until this point in time, we've been using interest rates. We already know how to calculate present values and future values using the interest rate method. When we work with interest rates, we use a positive exponent to take money forward in time, from the present into the future. When we want to work backwards from a future value to a present value, we use a negative exponent. If any of this is not crystal clear, I'd recommend that you re-watch the videos where I explain these concepts in more details. I will post a link to the videos below. Instead of using interest rates to calculate a present value or a future value, we can use something called a discount rate. So we'll start out with a really simple example to show you how this works. Suppose you have an obligation to pay $1,000 in 1 year's time. We want to calculate the present value of this amount using a discount rate of 10%. All we need to do is to multiply the $1,000 by 1 minus the discount rate. So in this instance, because we are using 10% for the discount rate, we'll end up multiplying the 1,000 by 0.9, and that of course is $900. The challenge with discount rates is the subtle differences compared to interest rates. Many students get confused and they mix up the concepts. It's easier to remember how we deal with a discount rate if you compare this to the way a store would price and discount stock. Indulge me for a little detour. I promise you we'll get back to the business of financial mathematics soon. Now imagine the day you've been waiting for has finally arrived. It's Black Friday and the shoes you've been lusting over for the past 6 months have finally been marked down to cost. If the shop paid $50 for the shoes and their profit margin is 100%, we can calculate the full or the retail price of the shoes as the cost plus the profit margin applied to the cost. And this is simply 50 plus 50 multiplied by the profit margin P. We can rework this by taking out 50 as a common factor, and that leaves us with the following equation. If we substitute P for its value, which is just 100% in this particular example, this is equal to 50 multiplied by 2, which is just $100. This formula is exactly the same as the future value formula, P times 1 plus I, except that we are using the profit margin in this specific scenario instead of the interest rate. If you recall the fundamentals of interest, we follow the same recipe. We start with the amount invested, or more formally, the present value, and we add interest to this amount. More formally, we start with the present value and then calculate a future value. Of course, as a customer, we don't know the cost of the shoes nor the profit margin that's used by the store. We only know the full retail price of $100 after the profit margin has been added to the cost of the item. We also know the discount rate advertised by the store. If the store marks down the stock by 50%, we can calculate the price that we'll be paying for the shoes as the full price less the full price multiplied by the discount rate. Mathematically, we can write this as 100 times 1 minus the discount rate. If we substitute for D, that becomes 100 times 1 minus 0.5, and that means that the price we pay for the shoes is $50. Now this formula is exactly the same as a present value formula when we are working with discount rates. And just a reminder, future value times 1 minus d gives us the present value. So the fundamentals of discounting are different from that of interest. Instead of starting with the amount invested and adding interest, we start with the final investment value, or more formally, the future value, and we subtract the discount. So we start with the future value and work our way back towards the present value. Of course, the direction can always be reversed by just manipulating the equation that we have at the bottom. When working with interest rates, we know that we add interest to the present value to obtain the future value. That is the natural order of things. If we need to reverse this calculation, we divide both sides by 1 plus I. The term cancels out and we are left with f times 1 plus I to the power negative 1 is equal to the present value. Now the exact same applies for discounting. If we divide by 1 minus d on both sides of the equation, we obtain f, or the future value, is equal to the present value times 1 minus the discount rate to the power negative 1. This can be rewritten as present value equals future value times the discount factor. Drawing from our existing knowledge, we know that we can simply raise v to the power n to calculate the present value of an investment that matures in n years' time, as opposed to 1 year. We can do the exact same when we're dealing with discount rates. So instead of having 1 minus d to the power minus 1, we replace that with the number of years n, and we have a general formula for the future value. Of course, we can do the same for the present values. Now, I've purposefully put the formulas for interest and discount side by side so you can take note of the subtle differences between these methods. Interest rates use a plus. In other words, interest is added, whereas discount uses a minus, which means it is subtracted or taken away. The exponents for interest rates follow the familiar pattern. A positive number to move money forwards in time and a negative number to move money backwards in time. The exponent for discount rates is the exact opposite. I have to admit this is a tricky topic to get your head around at first. As long as you follow the fundamentals described in this video, you should be able to find your way through the maze. For this exam, the majority of questions will specify an interest rate as opposed to a discount rate. So you may rightly ask at this point why I spent all this time yapping about discount rates. Although questions will typically specify the interest rates, most questions will require you to evaluate multiple cash flows and not just one like we've done up until now. So when you encounter a scenario like the following, $1,000 at the start of each year for the next 10 years, it's fairly straightforward to write down a formula for the present value, which is 1,000 times 1 plus v squared plus, and I use ellipses to indicate the terms that I'm not writing out, plus v to the power 9. Although it's pretty simple to write out this equation, punching this into your calculator is a whole nother matter. Firstly, it's time consuming, and secondly, it's also error prone, so the likelihood of you making a mistake is very high. So in the upcoming videos, we will hone in on formulas that we can use to help calculate the total present value when we are dealing with large numbers of cash flows. For now, all you need to know is that many of these formulas will depend on the discount factor. So to use these formulas, we need to calculate the equivalent discount rate for a given interest rate. The algebra is fairly straightforward. So we know that the present value can be calculated using two different methods, our interest rate method, and we can also use the discount rate method, which means that f will be multiplied by 1 minus the discount rate. Now for these two rates to be equivalent, the two present values have to be the same number. That means we can set f times 1 plus I to the power minus 1 equals f times 1 minus the discount rate. We can cancel out f, and we know that 1 plus I to the negative 1 is just equivalent to v. So v equals 1 minus d. We're interested in the value of d, not 1 minus d. So we subtract 1 from both sides of the equation. That yields v minus 1 equals minus d. And then we multiply both sides of the equation by negative 1. I'm also going to swap the order of these two values. So that means the sign of d changes since I'm multiplying by minus 1. And remember, if I multiply negative 1 into this equation, we need to change the sign of both terms on this side of the equation. So that becomes minus v plus 1, which is also just 1 minus v. We can simplify this equation somewhat by reverting back to the definition of v, and that is 1 plus I to the power negative 1. So as a reminder, the laws of exponents allow us to move numbers from the top to the bottom of the line or vice versa by simply changing the sign of the exponent. So we know that this x to the power negative 1, although it's not written explicitly, is actually divided by 1. So we can turn this whole number into a fraction without changing the value. What the law of exponents allows us to do is to move x to the negative 1 to the bottom of the line by simply changing the sign of the exponent. So that's the same as 1 divided by x. So we can rewrite this as 1 minus 1 divided by 1 plus I. To simplify the right-hand side of the equations, we need both numbers to be fractions with the same denominator. A number divided by itself is just 1, so we can rewrite the first term as 1 plus I divided by 1 plus I to ensure that we now have the same denominators. The second term will remain 1 over 1 plus I. Now, since we have the same denominator, we can say this is equal to 1 plus I minus 1 divided by 1 plus I. And this is simply equal to I divided by 1 plus I, since 1 and negative 1 cancel each other out. Finally, we have a formula for D, which is I divided by 1 plus I. We've covered a lot of theory in this video, so I want to end off with two examples. For the first example, we assume that you can invest your money at 10% interest per year. And the question is to calculate the equivalent discount rate given this interest rate. If you know the formula for D, this is pretty straightforward. This is just the interest rate divided by 1 plus the interest rate, or 0.1 divided by 1.1, which is just 0.0909, or 9.09%. For the second example, suppose that you invest $350 and the discount rate is 5% per year compounded. Calculate the future value of your investment after 8 years. So in this scenario, we are asked to calculate the future value f. So we know that the natural order when you work with a discount rate is you start with the future value and you work your way back towards a present value. We also know that we subtract discount from the future value. When we follow this natural order, in other words, we are calculating a present value, we start with a future value, then we use a positive exponent. Now, this particular question is asking us to go in the opposite direction. A present value is given and a future value is required. So the sign of the exponent needs to change. Once you know this, it's pretty easy to work out the values. Future value equals 350, which is the present value. We know that we add interest, but that we subtract discount. And then finally, we use this cheat sheet at the bottom. We're looking at scenario 2, so the exponent is -8. When you work out the numbers, it's $527.57. Many students need to work through these concepts a few times before they stick, so do not get discouraged if you didn't get this on the first go. Watch the video again and post comments or questions to your fellow students or to me if you're confused by any of these concepts. The most important is to remember the two equations. 1 minus d is equal to v, and the definition for d is equal to I divided by 1 plus I. And that's really all you need to know about discount rates. I hope you've enjoyed this video. Thank you for watching. Please feel free to leave comments or suggestions, and good luck with your exam preparation.